if you've watched the channel for even really a short period of time, you've probably heard one of my stories about my old days on VAX mainframes. Well, that leads into our latest project, where rather than building a giant version of something that already exists, we're going to make one that's quite a bit smaller. Right, so here are, well, the bits. So this model is obviously, as always, freely available on our GitHub and on various printing places like Printables and MakerWorld. Unusually for us, we actually released this before we made the video, just because so many people were asking about it that I just decided just to put it out there. Right, so this is, as you hopefully guessed from the intro, a Raspberry Pi case shaped in the same shape as a digital VAX mainframe, or mini computer really. So this is styled around the 11780, mostly because I kind of like the color scheme with the bluish lid. So I'll put a picture up somewhere so you can see the actual machine. This isn't perfect scale or anything like that, and the front panel definitely isn't, because I wanted this for a future part of this project, which we will discuss in a minute, to be able to take some actual components. So we'll discuss that afterwards. But anyway, this is what you need to make it. Again, all the plastic parts are freely available to download and print yourselves. I've used my multi-color 3D printer, my Bamboo one, to print these. So some of the bits, like this front panel, the fascia for the front panel, that's got some fancy coloured printing on there. You don't have to do that. I'm going to put a sticker design up as well, so you can just get stickers printed if you just want to print that in pure black and then put a sticker on it. Equally good. I saw someone actually using those wet slide transfers. I might try those because they look like they could be pretty cool for this kind of thing. But anyhow, this is what you need. So this is the base that will hold the Raspberry Pi. Obviously you need a Raspberry Pi, that you have to supply yourself. It should fit any Raspberry Pi. I've tried it with this style and with this style, and they both fit. Obviously this one you won't have the USB ports coming out the side because this is a lot thinner, shorter, but you can put stuff in and into that still, so that's fine. So anyway, to put this together you need all these plastic parts. I've put the wheels on the bases already, so these wheels are actually separate pieces of plastic. I'm stupidly proud of these wheels. These are kind of printed in place. They're not a great design for that, but I printed these in place. And then just to break off a lot of support material to get them to turn and stuff. But anyway, so I pushed those in place already. They just push in place things. And the rest of it should be relatively easy to print, relatively. So, other than the printed plastic parts and the Raspberry Pi, you also need 2 M2 screws to hold the Raspberry Pi in place. There's space for 4, so there's 2 posts there, and there's 2 posts on, here we go, the front part. No, that's not the front part. Where's the front part? Oh, back part, there we go. And 2 on the back part. You shouldn't need to put screws in these because the Pi that you go into this little groove here, and that holds it in place anyway. I haven't bothered putting it in there, but you can if you want to make sure it's fully secured. Screwdriver's right here. So anyway, I will start constructing this, and you should be able to get an idea of how it goes together as I put it together. All I've got to do is remember which way this goes. I may have made the model, but it doesn't mean I remember how it goes together. Yeah, that's right, like that. Okay. Right, follow along, if you will. And there we go. That's the fully constructed model. So this obviously, you'll see that these are a bit loose, and the lights, again, this is kind of part 2, if you will, when it eventually comes, is there will be electronics behind this, I'm hoping, if I can get it all working correctly. If you want, for now, just use it as a model, you can just glue these things in. I might make a kind of back thing for that to hold it in place, in case you wanted to actually turn as well as part of a model. But anyway, as you can see, and yes, I'm sorry about the noise, we have the ports out the side there, and the ports back there, so that's all usable. Yeah, that's just flowing out. Don't worry, we don't need that just yet. It's not a problem. So, yeah, these are all constructed switches. I've got a better way of doing this for the electronics board, which I will obviously, yeah, I'll update the model as we do that. But yeah, so what we need to do now is actually make this work as a VAX, as a DEC VAX. And the way we do that is we use an emulator called SimH. So what we'll do is we will go off now and install that. Right, this is almost certainly going far too far back, but we need to install the Raspberry Pi first. That's all pretty easy generally. Using the Pi Manager, it's literally, yeah, it's just clicking those. Now I'm going to set these settings. Now all these are, what I turn on is the automatic login with username and password, and configuring the wireless LAN, and also turning on SSH. So it just makes it a lot easier, because it means you don't have to sit there with the actual Pi and type all the stuff in. You can just use your own laptop and copy and paste. Up to you if you do that or not, but it's just a bit handy. So yeah, it will take as long as it takes. This is one of the smaller distributions of Raspberry Pi, because it's the older one, 32-bit version, and it's a bit smaller than the newer ones. So it won't take as long, but it will take some time, obviously. Anyway, once that's done, we can go and put it into the Raspberry Pi and boot from it, and then we can start with actually getting SimH set up. Right, so now once you've got your Pi set up, you can SSH into it. If you're not sure how to do that, then there are tons of videos on in YouTube to show you how to do it. They'll do it much better than I can. But anyway, so here's what we're doing. We're cloning from the GitHub. Now this is my own GitHub. It doesn't need to be. You can clone from the actual main SimH one. The link to that will be in the description below. And there we go. So now we need to actually compile. First of all, though, what we're going to have to do is actually install the dependencies for compiling. And if you pause after I do this, you'll see them. And there they are. Nope, there we are. They're the instructions. Yeah, we're looking at Ubuntu Debian. And I could just push the copy button. I'm recording this after the fact, by the way, in case that's not very noticeable. Yeah. Oops, I've got a hash in there, which I need to remove. There we go. That will, oh, yeah, okay. And we also need to do sudo, because we're not actually the administrator, or we're not root. There we go. So what this will do is it will go off and it will find all those packages and install them. And these are all the bits that we need to actually compile SimH. Right, there we go. So now we have put all of the dependencies in place. So now we can actually go ahead and compile SimH. So what this is doing now is this is just making the VAX. Now SimH supports lots of different emulators. So what we're doing here is we're just saying just do the VAX, and it's going to put the result into bin when it's done. Once again, this will take however long it takes. It's never short. It's a big, complicated program. So we will obviously skip this and hopefully it will compile. If not, then you'll need to take a look at the dependencies and make sure they all installed. Right, and there we go. And that says everything's passed. It's done tests on the code, so it's all compiled correctly. If we take a little look, oh no, it's a capital bin. There we go. And there we go. We have our VAX program there. So next things we need to do is we need to get some install media across. We need to put the EEPROM. Let's do the EEPROM. Okay, so the EEPROM firmware, boot firmware is in the VAX directory that came with SimH, and it's that, do you see that file I'm highlighting now? That's the file you need, and that should be copied into the same directory as the binary, or at least I do. I mean, you can technically edit the config file, which we'll do in a minute, to put it anywhere, but I put it in the same directory as the binary. And we will also need to create an ini file to actually configure it. And like I said, we also need some install media. Right, now I was part of the hobbyist program before they seem to have cancelled it or done whatever, I don't know. So I do have a copy of the CD-ROM. I can't give you a copy of the CD-ROM, quite obviously, because it is still technically copyrighted. So you'll have to go off and find it yourself, but it's certainly around. And so what we're going to do is we're going to use SCP to copy it to our home directory on the Raspberry Pi. It will of course take, again, as much time as it takes. There we go. So that's what we need from our machine. Now switch back to our Raspberry Pi, and there we go. You can see the image file is there. So that's our ini file copied in. I will make a copy of that and put it up, and I'll put a link to it so you can just download that. And now let's run the VAX emulator. All right, so what the first things it's doing here is it's creating our NVRAM to store settings in, and then it's going to create all of those disk files that we mentioned in the config file. So these are all of our storage files where we're going to actually install stuff. This will take some time to do, as it's creating these virtual disks. We have fast forwarded past this disk creation, by the way, so it would have taken a lot longer than what you've just seen. A lot longer. There we go. Right, and now it's going to try and boot from, well, it's going to try and mount the CD image. It's found the format and it's found the volume name. That's a good sign. And now we see it's actually running the boot process. So what we had there, that first part was running actually in SimH. It wasn't running in any emulated machine. But this part is now running in the VAX emulation. Not VMS, this is just kind of a pre-boot environment, and what we have to do next is actually make it boot from the CD-ROM. The CD-ROM is DUA free is the logical name for it. So we should just be able to type boot DUA free, and that should boot the CD. Again, this will take a while. Now, what this DUA free actually is a backup set. So what we need to do is we need to restore what's on this CD onto the drive that we've just created, which is DUA 0. Again, this will take a little while. We have to enter in the time and date. Let's try modern. Will it accept? Is this year 2000 compliant? I actually don't know. We'll try putting in the current date and time. Right, so what it's going through now is the actual pre-boot environment. Well, it's actually, this is technically VMS because it's running from the backup set, but this is now trying to find all of the devices that are attached, which it should do because they're obviously virtual devices, so they should work. All right, so once it does this bit, we should get a list of devices. There we go. So just as long as we have 0, 1, 2, and 3, definitely we know we've got 3 because we've booted from it, but as long as we've got 0, 1, and 2, then we can say yes to the prompt that will pop up soon. There we go. So we can just type yes now to say that we have all of our devices, and that's it. We have configured the boot, the backup, so now we need to restore it. So we are going to restore this backup set onto actual hard drive. So there we go. So that's the name of our restore set. It's obviously VMS 7.3, so that's what that is. And DUA 0 again is our primary hard drive, so we're going to be restoring onto that. If you have a different version of VMS, that's obviously going to be a slightly different line. All right, now this bit will take quite a while. There we go. So I get this wrong a couple of times, if I remember rightly. We should just be typing yes to continue. I misread it. It's been a while since I did this. It's not. I'm thinking it's asking Dawn to do another backup restore. In fact, it's just asking, "Are you done?" So we do yes, and that's it. We have technically installed VMS. Now we haven't set VMS up, but we have installed it. So what we need to do now is actually change our boot device and then boot. But first of all, of course, hello. What's happening here is I'm trying to type in SimH commands in the actual VMS prompt. So we need to Control and E, I want to say. Control and E will take you out of the emulation and back to SimH. So now what we want to do is boot CPU, and this will boot. Right. So now we're kind of in that pre-boot environment again. So I said VMS, the VAX device. We're now in the pre-boot environment, and we can set our default boot disk. So we're changing that so it's our primary disk hard drive, DA0. And now when we type boot, instead of booting from the CD-ROM, this time it should boot our unconfigured VMS system. Right, here we go. So this is now starting the installer. We get to put in the date and time again. Okay, so now what will follow will be an awful lot of configuration things. Most of it are fairly obvious, so I think we'll probably just skip past a few of them. We'll let the first one pop up, ignoring all these. Don't worry about this. Right, we'll just use the default for this. This will be DUA free. This is our CD-ROM that we booted from originally. Yes, it definitely mounted. Already mounted. Right, so now it's basically just a whole, what do we want to install? We'll install most of this stuff. We have the luxury of having the largest hard drive we could have got, so not a problem. Apart from the management station, I don't think we need that. But we'll absolutely be installing DECnet. Not that we'll be able to get it working, I suspect, but it's we may as well. DECnet, we don't really need it, but we'll install it. DECnet Plus, that is. Right, so now we've said yes to that. This is now actually installing all of this stuff. This will take a fair while. Right, and there we go. So yeah, we may as well have Motif as a default windowing system. All right, so now passwords. Don't put any weird characters in these passwords because you may end up locking yourself out. I have discovered that the hard way in the past. I would, just use numbers and letters. It's the easy way. So I will enter my super secret password of piVAX test. Ignore that password, obviously. That's super secret. And it will be using the same password I use for everything on this machine, obviously. So now it's creating a bunch of stuff. Right, so the node name I put in wrong here, I think. I think it's the ID, the node ID, and it's not. It's actually a name. So basically anything alphanumeric, 6 characters or less. I think I'll just do piVAX or something. Indeed I do. There we go. This is the ID, this is the number, and that's not even high enough. That's 1026 I think I put in for this. All right, so now it's mostly kind of automated, just setting stuff up, going on. Right, so no, because we don't have any licenses. Licensing is something that's going to be interesting. There is a way around it. I probably can't tell you it, but who knows? We'll find out. Right, so yeah, obviously location. We'll go for GMT. Yep, that's right. And GMT again. And yep, time differential is fine. Right, now it's asking for our installed drive again, which again is DUA free. And yep, it's ready to be mounted. I'll break in here to say that this step this whole VMS images step, or wherever it's doing while this is displaying, takes a long time sometimes, so don't worry if it freezes here. Right, and now it's finished installing, so it's just going to shut down the system. In our case, of course, it will just go back to SimH. Right, we're back at SimH, and now we need to restart again using boot. And then once we get into the VAX pre-boot environment, there we go, we can now boot again, and it should boot from our newly installed copy of VMS. There we go. We have our successfully installed message. It's still obviously doing stuff though. And there we go. Now we're at this part, we can push return. It should bring us up a login prompt. There we go. And we can log in now as our system account. We have a VMS installation, and now we're going to shut this down safely, and we can continue with our VAX, piVAX system. Right, so there you go. It's a very simple project. The next bits we do will hopefully make it a little bit more sophisticated, and we do have kind of a third part to this, which there's not a lot to show. I guess we can show one thing, if I could just dig it out of this pile here, which if you know your DEC stuff, you probably work out what that is. But yeah, I think it's a nice model anyway to make. It's nice, a nice pie case, an interesting bit of history as well. I will say, by the way, we are sitting, this is sitting, someone will ask, because they always do, this is sitting on top of a rather lovely Thomson T09 computer. Video coming, obviously, to meet up with my other Thomson videos. Yeah, so during the video, I kind of used my own branch of SimH, and the reason for that being is I'm not sure if their front panel stuff will cope with what I want to do. Feel free to use, obviously, the main branch SimH. There's no reason why not at the moment. You can always pull in my changes if I make any. But yeah, anyhow, thanks for watching. If you like the video, please hit like. If you really like the video, please hit subscribe. If you didn't like the video or you have something else to say, then please leave it in the comments below. See you next time.
The present is horrible, the future looks bleak.